Last day before test number 5. It's more of the same of the retake you took yesterday of test number 4, which is y equals mx plus b. There's a lot of matching equations to graphs. The thing that's a little bit different about this test, it takes it to the next level, is also recognizing the x-intercept from a graph. So that's the two things I'm going to go over today. I'm going to review graphing an equation. How do you match an equation to a graph? And then I'm also going to review x-intercepts because I talked about x-intercepts exactly a week ago, last Thursday. So if you want to study for the test tomorrow, you should start from last Thursday and watch that video because that talks about x-intercepts, and you definitely need to know something about x-intercepts for the test tomorrow. Every other day is good too because they all talk about y equals mx plus b, but we've talked about that a lot, and I'm going to talk about it again today. So if you really want a focused study, watch last Thursday and today and anything recent. Okay, how would you match this up to a graph? You would look for a graph that had the line going down and cross the y-axis at 5. It would be right there. So your line is going down to the right because your slope is negative. This right here is the slope because it's next to the x. The fact that it's negative means that the line is going down. And then the y-intercept is a number by itself. It's a plus 5, so it's up at 5. So it would look something like this. Now let's be more specific. Let's see what it really looks like. What is the slope of this line? Did I draw that at the right angle? Should it be going down more steeply? Should it be a little bit flatter? Let's see. That might be enough information right there to pick the right answer on the test. That might be the only choice that's going down and crosses at 5. So you might be done. But you might have two choices that are going down and crossing at 5. So if that's the case, you got to see if that line is at the correct slope. So how do we find another point on this line? Here's one point. That's our starting point. That's our y-intercept. From the starting point, rise over run. In this case, we're going down, so we're going down 5 and over 2. Well, down 5, 1, 2, 3, 4, 5 gets us to the origin, and then over 2 would be right here. So that's actually where the line should cross. So our line should look like this. Oops, I still missed. Yeah, I touched the edge of it. That counts. All right, so that's what our line looks like. It's going down. It crosses the y-axis at 5. And then the next point is on the x-axis right here at 2 because it went down 5 and over 2. Down 5, over 2. 5 over 2. 5 over 2. Rise over run. It's negative because the line's going down. All right, the next part that I want to talk about today are the x-intercepts. You're not really going to find an x-intercept from the equation. Now you can, and that's what I talked about last Thursday. You can find an x-intercept from the equation by making y equal to 0 and solving for x, but you're not going to have to do that tomorrow. All you're going to have to do is look at a graph and say, what is the x-intercept? Well, it's the same concept as the y-intercept. What's the y-intercept in this one? It's the point where the line crosses the y-axis right here, 5. So the x-intercept, you could probably imagine or already know, is where the line crosses the x-axis. So where does the line cross the x-axis? Right here at 2. So the x-intercept is 2 in this one. The y-intercept is 5. And that's it, people. That's all you got to do to find the x-intercept. Where is the point on the x-axis that the line intersects it? You guys should be able to find the point where two lines cross. The part where that may be a little tricky is that when they ask you to find the x-intercept from a picture, which I'm calling a graph, it may not necessarily be a straight line. So you might get an exponential function or a quadratic function. And you might be thinking, whoa, what do those words mean? We're taking the test tomorrow. Why are you just introducing exponential function and quadratic function? I'm not really introducing them to you. You don't need to know what those functions are yet. We'll learn about them later this year. All you got to know is that they both could potentially cross the x-axis. The quadratic function is just a u-shaped parabola. But notice it crosses the x-axis still. This is the x-axis, and even though our graph is a curve now, it still has an x-intercept right here, another x-intercept right here, and it has a y-intercept right here. X and y-intercepts is just where your graph crosses those axes. It doesn't matter what your graph looks like. So let's say this is point 1, 2, 3, 4, and this is 1, -2. So it has two x-intercepts, -2 and 4. This would be 1, 2, 3, 4, 5. We'll say that's -5. And the y-intercept would be -5. So it doesn't matter if the line is straight or if it's curved. Wherever it crosses the x-axis, that's an x-intercept. Wherever it crosses the y-axis, that's a y-intercept. Right, that would be a quadratic function. That would be a parabola, which you really don't need to know that. All you need to know is where does the line, the graph, cross the x-axis or the y-axis. If it was an exponential function, it would look like basically half of a parabola. It would look more like this. And then same concept. What's the x-intercept? This point right here, x-intercept. What's the y-intercept? That point right there. See. So those should be easy problems. When they show you a picture and say, where does the line cross the x-axis, or what is the x-intercept? That's what they're asking you. What is the x-intercept? It's where the line crosses the x-axis. It doesn't matter if your line is a crazy squiggle or if it's a straight line. That's an x-intercept. That's an x-intercept. So don't worry about the shape of the line. Just worry about where it crosses the x-axis.